Alright, here's the second review video for the third exam, and it starts with the inverse, calculating the inverse function and verifying it. And so the function that we're supposed to take the inverse of is 5 minus the quantity 2 minus x cubed. When I say the quantity, that means something inside parentheses. So remember your steps for calculating an inverse. You first write the equation f of x equals, there's the function, and then you put y in for f of x. Then you swap the x and the y, so that then this is, instead of being y, this is x, and instead of being x, this is y. Then you solve for y. And so I subtracted 5 from both sides of the equation here, and then I factored, or I multiplied both sides of the equation by -1. It's not really necessary, but I just thought it would be neater and tidier if I did that. When you multiply x minus 5 times -1, as I've said before, that reverses the direction of the subtraction, and a negative times a negative is a positive, so I have on the left side 5 minus x, and on the right side the quantity 2 minus y cubed. Then I take the cube root of both sides, and the cube root of the quantity 5 minus x is left. There's no simplification to that, but the cube root of a cube cancels, those operations cancel one another out because they are one-to-one and invertible functions by themselves. So that gives you 2 minus y on the right side and the cube root of the quantity 5 minus x on the left. You subtract 2 from both sides and then multiply both sides by, or rather I added y to the left side and subtracted -2 and subtracted the cube root of 5 minus x from both sides. Anyway, I think I'm fumbling all over myself here because it's midnight and that's past my bedtime. I don't know about y'all, but anyway, then you rewrite f inverse for the y, and now that is your inverse function. Now to confirm this, you compose either f with f inverse or f inverse with f. I've done both. So to compose f with f inverse, wherever I've got an x in the function f of x, I put a set of parentheses, and in those parentheses I substitute in the f inverse. Well, the f inverse is 2 minus the cube root of 5 minus x, and to refresh your memory, the function is 5 minus the quantity 2 minus x. So here's the x, and we put the parentheses there and substitute in the inverse. Well, 2 minus 2 is, I distribute the negative here, and I have 2 minus 2 and minus a negative cube root of 5 minus x is positive cube root of 5 minus x. 2 minus 2 is 0. And so this simplifies to 5 minus the cube root of 5 minus x cubed. Well, cube root of 5 minus x cubed is 5 minus x. And then when you take the parentheses, when you clear the parentheses, that means you're distributing the negative through here. So this is -5, and a negative x is positive x. 5 minus 5 is 0, and that just leaves the x, which is the verification that we were looking for. Now, to compose f inverse with f, remember here's f inverse, and so we've got an x inside this radical. So we put a set of parentheses there, and inside those parentheses we substitute in the function f of x, which was 5 minus the quantity 2 minus x cubed. And so inside those parentheses we distribute the negative here, 5 minus 5, and minus a negative 2 minus x cubed is a positive 2 minus x cubed. So 5 minus 5 is 0, and that leaves the quantity 2 minus x cubed inside the cube root, and the cube root of the cube, once again, cancels out, so this is just 2 minus x, and when we distribute the negative across these parentheses, that's 2 minus 2, and minus a negative x is positive x, 2 minus 2 is 0, so again, we have x, which is what we need to end up with to verify that two functions are the inverse of one another. Okay, now here's a series of equations that we're solving. We're using properties of exponents, properties of logarithms, and properties of logarithms to solve them. The first one is 7 to the 4x equals 49 to the quantity 1 minus x. And remember, we would like, if possible, when we have a couple of exponential expressions, we would like to write both sides of the equation with the same base. Well, 49 is 7 squared, pretty easy to see. So we write, instead of 49, we write 7 squared, but we put that in parentheses, and we put the exponent in parentheses for the purpose of keeping track, for emphasis, to remind us that that entire expression is the exponent. And then I pull the 2 outside the parentheses, and I multiply the 2 times the 1 minus x. So now my new exponent is 2 minus negative 2x, because 2 times 1 is 2, 2 times negative x is negative 2x. Then I use the uniqueness property of exponents, which says that if we have the same base with different exponents on either side of an equal sign, then those exponents have to be equal. So that means 4x is equal to 2 minus 2x. I add 2x to both sides, that gives me 6x equals 2. Divide both sides by 6, and so I have x is equal to 2 over 6, which is equal to 1/3. Now you can verify this by substituting 1/3 back into the original equation if you want, but it's not really necessary. I don't ask you to do that on the exam. Now, next equation, 3 to the x squared minus 2x is equal to 3 cubed. And those are already, this is already, I can't hardly believe that I gave a question where the bases were already the same. Perhaps I did, but in any case, the bases here are the same, so we just set the exponents equal to one another. X squared minus 2x is equal to 3. We subtract 3 from both sides, and we have x squared minus 2x minus 3 equals 0. That factors very easily as x plus 1 times x minus 3, which tells us that our solutions are -1 and 3. Now let me just warn you right here, somebody is going to do this because somebody always does. You can have a negative solution for an exponential equation. You can't usually have a negative solution for a logarithmic equation, but don't confuse those two. -1 is a valid solution to this equation. If you put a -1 up here into these, substitute a -1 in here, you'll wind up with 3 to the third is equal to 3 to the third. 3 cubed is equal to 3 cubed. Alright, now the next one has, we're taking the logarithm base 2 of a fraction set equal to x, and so we want to find out what this x is. So we write the 16 with a base of 2. 16 is 2 to the 4th, and it's in the denominator, so I bring it to the numerator by changing that +4 to a -4, and logarithm base 2 of 2 raised to anything, logarithm base 2 of 2 with a base. Those are inverse operations, they cancel one another out, and that just leaves -4 is equal to x. Now you could on the other hand, change this. You have an option. You have more than one way to do this. You can rewrite this equation in exponential form by bringing the x over here as the exponent and the argument, the 1/16th, over to the right side of the equation. Remember, we did that with that arrow arch in the handout. If you look at that, there's arrows going back and forth between here and here. Anyway, so we now have 2 to the x is equal to 1/16, and so yes, we write the denominator 16 with a base of 2 because it's 2 to the 4th, and bring it to the numerator with a negative exponent. 2 to the negative 4 is equal to 1/2 to the 4, and so that means that these exponents, we can equate these exponents, so x is equal to negative 4.